Welcome to all in our youth story. My name is Sujan Das. Today we will learn the main base of mathematics, mainly the main base of pure mathematics in our youth story. Basically, the base of mathematics lies on theory of set. At first, we will study the set theory and allied concepts. For our purpose, we will follow this book, set theory and related topics from some outline series. This is a good book, and we can also follow others book, but at the beginning we will follow this book. So sets, and we are going to learn sets and some basic operations. Sets operations means addition, multiplication, subtraction. It's actually the concept of set appears not only in mathematics but also each topic of science and technology. At first, we will define the set mathematically, then we will go further. Set, we can define, or we adopt the definition from here, that a set well-defined collection of distinct objects. That means here two crucial points are well-defined collection and distinct objects, but we will take here not objects, distinct objects. So basically, two main characteristics, well-defined and distinct objects, means in a set repetition we can't allow any repetition, and well-defined means any object, whether we can take or we reject the object, that will be specific, that will be fixed. There is no ambiguity for taking these objects. This is called well-defined, and distinct objects means no repetition. We reject repetition. These two characteristics are the main thing of our definition of set. So we can define, suppose we are going to collect the numbers 1, 3, 7 and 10, and here if we look that 1, 3, 7, 10 all are different, and second thing, well-defined, they are well-defined collection. So we can say the numbers 1, 3, 7 and 10, this forms a set mathematically. Now if we see the second degree equation, x square minus 3x minus 2 equal to 0, then the solutions of the equation, of this equation, suppose square 0, then we can write 1, 0, but now okay, then roots are x equal to 1, 2. From here we can write square, then x. In this process, we are unable to find the roots, so we use another method for finding the roots. Direct method, minus of 3 b square minus 4 a k. Then 3 plus minus this is equal 3. So the roots of this equation are 3 plus square root 17 by 2, 3 minus square root by 2. There are two roots, they are distinct, and of course this collection well defined, so this forms a set. Now similarly, the vowels, the English alphabet A, E, I, O, U, all are distinct, and we are taking the vowels only, so this is specific. So this collection again forms a set, and the people living on the earth, they are all distinct. Maybe they are identical, but according to DNA structure, etc., they are all distinct, and the collection is well defined, since we are taking only people, not any other. The people, the students named Tom, Dick, and Harry, they are all distinct and well defined collection. So sets. The students absent from school, 6th day, etc. The even integer 246, the rivers, the United States, maybe India, they form a mathematically set. Now we define the set, concept set. Now we use a notation for set, and for this we use capital letter from English alphabet A, B, C, D, etc. And for element of the set, we use lowercase letters, small a, b. Now consider this set, capital A, consisting of vowels from English alphabet A, E, I, O, U. Means that A is the set whose elements are the letters A, E, I, O, U, and we use the elements are separated by commas and enclosed in braces. That means nickname second bracket. The second way, state those property which characterize the elements in the set are in this tabular form, and this is the most famous form of defining a set. We can write B x. This means such that x is an even integer and x greater than 0. This means we are taking those x which has two character, greater than 0, positive, and they are even in nature. So we can write easily 2 belongs to, here this symbol belongs to, we can say that, or we can say that 2 member of B. but 0 doesn't belong to E. 0 is even, no doubt, since 0 can be written as 0, 2, 0, even integer, no problem. But we are taking only positive integer greater than 0, so we can't take 0. So 0 is not member of this set capital B. And now suppose we take two sets A and B and we define they are equal, means the number of members in the set are same. Maybe consider this set A. Elements are 2, 4, 10. Another set B, 1, 3, 7. Now number of elements in the set capital A 3 and B is also 3, but number of elements in C is 2. So we can say capital A equal to capital B as a set, but they are not equal to C as a set. Now this symbol means belongs to A, or B is an element of A, or B is a member of A. This negation, B doesn't belong to A, means B lies outside of A. Now we put a vertical line or line through a symbol to indicate the opposite or negative meaning of the symbol. Suppose A belongs to capital A. Now this type line plus we use to define the opposite of this meaning. That means this tells us that small a is a member of capital A, but this tells us that A lies outside A, it is not a member of A. Now consider this set capital A, where we are taking those elements X, letter of English alphabet and vowel. So we are rejecting the consonants. Observe that B doesn't belong to A. B is not a member of A, since B consonant, not vowels, but E lies in A, but B not in A. Now consider another set capital B, where we are taking these elements 2, 4, 6, etc. That is even numbers. 9, we know that 9 is not even number, so 9 not a member of B, but 8 even number, 8 belongs to B. Now consider this set I think this will be, sorry to say, and this will be square. Now E is the set of roots of the polynomial equation x square minus 3x. If we find the roots, this will be x minus 1, x 0, then 1, 2 roots equation. So E is explicitly 1, 2. And consider E x such that this is equal to 0 and f equal to 2 comma 1. Then e and f are both equal since the number of elements in e and f are 2, so they are equal. Now if we consider g, here this book has no restriction on repetition of the set, so they write this type form, but basically g will be 1 comma 2 comma 6 by 3 means 2, 1 comma 2. Basically both, they are all equal. Now we define natural number from 0, 1, 2 dot positive integers, sometime the standard notation plus this in set symbol, set of integers, set of rational number q, set of real number r, and set of complex number c. Sometime we are unable to express the set with its element, or if we consider an infinite set, then it is impossible to write down all the elements of this set. In this case, we adopt the set builder method. It will better to express the set. Now we consider universal set, means universal set A has a property P that there may be no elements U which has the property. This is crucial point. Empty set means, suppose consider this set x is a positive integer and will be 3, then there is no elements as that, no positive integers as that x square equal to 3. So basically there are no elements in this set. Basically, according to mathematicians, this we called the empty set, and the notation for it, we take this notation for empty set. Now suppose, consider two set A. Now if every element of this set also a set, then we called a subset of. If every element of B also element of A, then we called. And if at least one element of A doesn't belongs to B, then we say that A not equal to B, or A not a subset of B. Now consider this set 1, 3, 5, 8, 9, 1, 3, 1, 2, 3, 5, 7, 1, 5. Then C subset of A, since 1 belongs to C as well as A. 5 member of C, the member of A. C subset of A. Also 1 and 5 also member of B. C also subset of B. But now if we take it A and 2 belongs to B, but 2 does not belongs to capital A. So B at least we have one element 2 member of B but not a member of A. Also 9 A 9 not a member of B. So A of at least we have one element, namely 9, that A has element 9 but 9 is not a member of B. Now if we consider this set of all positive integers, also members of natural number, and that each natural number, of course integer, each integer rational number, each rational number real number. So we write this chain of subsets. Better to write P as n plus sign, n plus subset of n, subset of z, the subset of q, this is the chain of subset. Now consider this set E equal to 2 4 6 F 6 2 4. They are basically same, they are same number of elements, and the crucial point, every set is a subset of itself, means because okay, since if we consider any set A, then each element of A, also element of A, we can write A is a subset of A, and every set A is a subset of universal set capital U, and the definition, by the definition, empty set also subset of A, because empty set has no member, so this is holds trivially that empty set of any set, since it has no member, and every set subset of universal set capital U, means since any element from this set also belongs to a universal set. Now every set is a subset of itself because trivially holds trivially. Every element of A belongs to B and every element of B belongs to C. Then clearly look at suppose A and B subset of, then every member of A member of also member of B and every member of B also member of C. So basically if we take any element from A, this implies, this sign implies, then X belongs to, this tells us if X belongs to B, this implies X belongs to, combining this and this, we have if X belongs to A to C. this implies A but if A subset of B and B subset of C, then A subset of C. And the crucial points, if A subset of B and B subset of A, then they are same. Conversely, if they are same, then this condition holds. So if we try to prove that two sets are equal, then we have to prove, suppose we are given sets A and namely A and B, and we have to prove that A equal to B, then first we have to show A subset of B and B subset of A. Next, for any set empty subset of A subset of U, or any set A subset of A subset of B subset of C implies A subset of C, and A equal to B if and only if this condition holds. Now, suppose A subset of B, then the question, then it is still possible that A equal to B. Means if B equal to A on every set subset of itself. So A subset of B, there are two possibility, either A equal to B or A not equal to B. When A subset of B but not equal to B, in this case we say that A is a proper subset of B, and we write by this notation A proper subset of B. For example, 1 3 1 2 3 and 1 3 2, A is a proper subset of B, and B and C are of course equal. Disjoint sets, two sets A and B are disjoint if they have no elements in common. If we consider A equal to 1, 2 and B equal to 2, 4, 6, then 2, we have member 2 lies in A, 2 lies in B. That is okay. We use the notation this for union, this for intersection. Two member of A and two member of B, these two conditions implies that 2 of A, that is 2 lies in both of A and B, the set A and B. So they have common element. In this case, A and B are not disjoint sets. But if we consider B and C, then also 4 member from both set B and C. So they are also not disjoint sets. But if we consider A and C, then they have no element in common. A and C disjoint set. Now, for representing sets and basic operations, we use Venn diagrams. Like this. If A subset of B, then the picture will be A subset A, since each member of A also member of B, so B may be equal to A or maybe this type of structure. that is B contains the set A, and if A and B are disjoint, then they have no common element. So A, B, they are this type of picture, and if they have common element, then this is the position, the number of common elements. Set operations. If we suppose we have two real number A and B, then we can easily add them, subtract, etc. basic operations. Similarly, we will develop the basic operation, namely addition, multiplication, etc. for the sets. At first, the basic operation will be union. The union of two sets means take all those elements of X, which member of A or member of B. The main crucial point, or means we take all elements of A as well as all elements of B. And intersection means we take all elements like both A, B. Then this will be A intersection B. Now, if A and B are disjoint sets, then of course this X, they have this X such that X member of A and X member of B, this will be empty set, because due to disjoint sets they have no common element. Now the structure will be A union B, means we take all elements of A, all elements of B, and intersection means common part. So this will be this position A intersection B, and for if they are disjoint, A intersection B equal to empty set. Now if A equal to 1 2 3 4, B equal to 3 4 5 6 7, C equal to 2 3 8 9, then A union B means, suppose we are interested to find A union B, then according to our definition we take all elements of A as well as all elements of B. So first we collect the elements of capital A. So 1, then 2, then 3, then 4. Now 3 and 4 also member of B, but we define the set as distinct elements and well defined collection. So now we write from 5 6 7. We will not write 3 4 again. If we write, then repetition will occur, but this violates the definition of our set. So A union B equal to 1 2 3 4 5 6 7. Now A union C, this equal to, this will be, at first we collect the all elements of A, and the result will be 1 2 3 4, and then all elements of C, such that the elements which are we collect from A will keep at this time. So basically 2 and 3 we already write it, we already collect here. So at this time we skip these two elements and write 8 comma. Now B union C, similarly B union C, at first we collect all the members of B, and then we will look the elements of C, and we collect all those elements of C which are distinct, which such that there are no repetition of members. And now we find out the intersection operation. Then suppose A intersection B, then before here, before also here, A intersection B, 3, 4, and A intersection C, this is equal to 2 is here, 3 is also here, 2 intersection 2, 3, and B intersection C, this is only 3, because 3 is the only common element. A, if we try to draw the Venn diagram according to this data of set, then the one picture will be looks like, say, this set capital A, this set capital, sorry, say A equal 1, B equal to 1, 6, C equal 3, then the corresponding Venn diagram looks like, say, here is set A, B, if this C, A, B, and C, then one is here, one is also here, and here. So this A and B have only one common element, namely 1. So this set A consisting of 1, 2, 3, 4. If we try to draw a set B, then B will be 1, 5, 6. 6 members will be placed here. C equal 0, 1, 2, 3, 9, 0, 3, but 2 is the member of C as well as of A. So we will place member 2 here. Basically, this is the one Venn diagram according to this. So we will easily draw Venn diagram of any number of sets. Now U be the consider university and U be the set of all students, M male student, F female student. Then all students, we neglect the case of third gender, etc. We are considering there exist only male or female students. Then number of all the students, either male or female. U can be written as union of two set, male set and female set. And now any student, either male or female. So these sets are disjoint. Their intersection be empty set. Now if we draw the Venn diagram, say A, B, then this part will be A, B. Now every element X in A intersection B is also, this is A, B, then this X also member of A and this X also member of B. Hence X belongs to A as well as B. Thus A union B subset of A and subset of B. So we can write mathematically or formally as A intersection B subset of A and A intersection B also subset of B. Now an element X belongs to the union A intersection B. Okay, if X and A union B, the position of all the collection of members. Now if X belongs to A union B, then this X has three choice, either this X, either this X in this part or this X in this part or this X in this part. So if X belongs to union A union B, then X has three choice, either this side or if this common side, then this is also member of A and also member of B. So this reduces that X member of A or member of B. So if we take X belongs to A, then X A union, that means any member of A also member of A union B, because at the definition we defined two union of two sets such that consider we take all the members of A and B such that no repetitions occurs. So each member of A also member of A union B and each member of B also member of A. So we can write A subset of A union B and B subset of A union B. Now we can write as A intersection B subset of A, this of A union B. If we draw a Venn diagram, then this will this if we draw a Venn diagram, say this is A, B. Then A, this is total A, B, this part A, so A intersection B, half part of this circle. So A intersection B, subset of A, and A union B means whole part of two circles. So A also subset of A union B, and similarly we can write this chain condition, this chain subset from A intersection B, subset of B, and B subset of A union B. Now the theorem says that these followings are equivalent. A subset of B and A intersection B equal to A, and A union B equal to B. Other conditions we will see it in problem later. We define complement. Complement means we take all those elements from universal set which not a member of A, then this will be complement of A. And if we look at this Venn diagram, then this set A, complement of this set takes all the members outside from A, so this part. Now we define if define set minus A minus B, or this notation. First, this is the standard notation for set minus. We define this set, we take all elements of X such that X in A, but X not in A. This collection gives the set A minus B, and the corresponding Venn diagram will be, this means this will be, then the corresponding Venn diagram will be this. We consider all elements A but not in B, so we delete the intersection part. Only this part will be the image form of set as A minus B, and we define symmetric difference of two sets by the notation, this or standard notation A delta B. This means A union B, A B. This is the standard definition of symmetric difference, and the corresponding Venn diagram will be basically, here we delete the members of common members from union of two sets. So image will be this, consisting of these parts. Since we delete the intersection part, so this part will be white. So next day we'll continue the next operations examples from IIT JEE various examination asked from topic set theory. involving this union, intersection, etc. And I have taken these contents from the book. This is a nice book on set theory from Thom's Outline series. We from now we follow this book strictly. Next day we'll solve few problems. Set theory. We will meet next day.